Today we're going to be going over solution stoichiometry. Oftentimes in chemistry, we're given the mass of something, so I'm denoting that as M. And mass is units of grams, so grams of bromine, for example, or grams of aluminum, Al. Another important aspect of chemistry is just finding the number of moles of a certain substance. So we can use grams of that substance and the molar mass of that substance to find moles. Let me just write that as grams over grams per mole. So for an example, we're going to use bromine. So the molar mass of bromine is 79.9 grams per mole. And let's say 100 grams of bromine. So I'm going to write 100 grams of bromine, Br, over, let me change the color, 79.9 grams per mole, so the molar mass of bromine. And that gives us 1.25 moles of bromine, Br. All right. So moving on. So for solution stoichiometry, however, we're going to be using volume. So volume instead of, of grams. So if we have a certain volume, so volume of, say A, we can use the formula molarity equals moles over volume. So think about this. Think about if you were given grams, you can use a molar mass to obtain moles, and you could plug that into this equation right here, right? So if we're given a chemical equation, we can figure out moles and grams or volume of the unknowns in the equation. So here's an example. How many liters of 0.25 molarity H2SO4 solution are needed to react with 0.25 liters of 0.1 molarity NaOH? So as I'm solving this equation or this problem, think about different ways that these units can be presented to you. A lot of these are interchangeable because we know many different ways of converting from unit to unit. So let's change the color. So the chemical equation would be H2SO4 plus 2NaOH yields Na2SO4 plus 2H2O. So we're going to start by writing the knowns down, and we know that there are 0.25 liters of NaOH, which has a molarity of 0.1. So we can use these knowns to find the moles of NaOH by using the formula, which is, let me just change the color, molarity equals moles over volume. Let's write that. So here we can start plugging in our values. You know that the concentration or molarity is 0.1, and we know that there is a volume of 0.25 liters of NaOH. So we can use just basic algebra using this formula to solve for moles, which we get 0.025 moles of NaOH. And then using stoichiometric factors, we discover that 0.025 moles of NaOH equates to, me just write this down real quick. 0.025 moles of NaOH equates to 0.0125 moles of H2SO4, because we divide 0.025 by 2 because of the chemical equation. So C2 and then 1 in front of H2SO4. So it's a 2-to-1 ratio, so we divide 0.025 by 2 to get 0.125 moles of H2SO4. And then using the same molarity equation, again, let me just change the color real quick. So now we're just going to reuse the same molarity equation with, we know that there's a concentration of 0.25 molarity H2SO4, and we know that we have 0.0125 moles of H2SO4, and then we solve for V, and that gives us 0.5 liters. So just think about this problem in a different way. Say we can change it from how many liters to how many grams of 0.25 molarity H2SO4. Just a different way to think about the problem and a different perspective using different units. And then we use different conversions to solve for that. Thanks for watching. I hope you enjoyed this video.